Then I think we just made it for all the relevant sources. So, yes. Hey guys, what's going on? Oh my god, I'm forgetting all the extra light and everything. Jeez, what's wrong with me? Yes, professional YouTuber. So, today's story is a wee bit different. I should probably actually balance it out. Oh god. This is what happens when you try to send to too many different locations. So, alright. Here we go. Gotta make sure everything is still working here. It's alright. It's alright. Ba-ba-ba-ba-ba. Alright. Testing 1, 2. There we go. Alright. Should be working there. So, hey guys, what's going on? Memes here. Today we're gonna be doing a little bit of something different just because I was like, what should I talk about today? And I can always talk about all the old stuff right there and everything. And like many times when I was thinking about something to talk about, an Anton Petrov video popped up, and apparently the Planet 9 hypothesis may be kind of bunk. So I know that's going to make a lot of people really sad, but it's relevant, and nobody would ever play the algorithm except for me. Yeah. But I digress. So let's go right into exactly what we might be talking about. So let me just bring up this little thing over here. All right. Bada boom, bada bing. All right. So here we go. No, we don't need to talk to myself. I do that enough. All right. So let's just pop in real quick to Anton. So if you're into scientific stuff and things without a lot of the BS and or over-the-top zaniness here, you can do what you want. I ain't your dad, but feel free to check out Anton if that's your thing. So let's just go right over here. And full disclosure, I am one of Anton's patrons because I shoot him a few bucks a month because, well, he provides a lot of good quality science news, in my opinion. So let's go right. Hold on. I need to make sure we're actually presenting the tab because otherwise there's going to be no audio. All right. So as we can see, the title over here, new dwarf planet may have basically just ended the Planet 9 hypothesis. What's going on, Anton? Let's check it out.
And it looks like researchers discovered something else super exciting on the outskirts of the solar system. We officially have a new dwarf planet that, despite being relatively small and despite having somewhat common properties, presents us with something really important when it comes to the search for the mysterious Planet 9.
Okay, so basically we've just discovered a new trans-Neptunian object. What is that? Because since Neil deGrasse Tyson destroyed Pluto, ultimately, here's the thing. We had Pluto as a planet. I'm still grew up with the whole, my very educated mother just showed us 9 planets. Why? Because that's a moniker to help you remember the names of the planets, because each word begins with the name of the different planets. Okay. The only problem is, how does one define planet? Because the generalized definition, to the best of my knowledge, is a planet is something that will end up creating a spherical style object, not a perfect sphere, but basically an actual spheroid under its gravitational attraction. The reason why Pluto doesn't necessarily qualify as an actual planet anymore is because it doesn't create an actual sphere itself. It's kind of there, but you look at it, you're like, all right, it's kind of out there. Plus, if you actually start discovering other objects like Eris and what did we call this one? Let's see, the candidate. Basically, it's a new dwarf planet. What do they call it? Let's just get back to Anton. I've rambled enough for fair use.
The object you see right here, referred to as 2017 OF201.
Okay, of course that's why I didn't remember it.
Does not actually exist after all. Or in other words, this is the first official evidence for the non-existence of the 9th planet anywhere in the solar system. And so let's discuss this new discovery.
Okay, so he goes in and we'll just, basically long story short is, you see all these things here, basically these ellipses are representing the planets as we know them. So zoom in real quick. Okay, we got our standard orbits and everything, but these over here are actually the trans-Neptunian objects because, well, their orbits seem to be quite eccentric, and the whole reason why Pluto ended up not being a planet is, one, it didn't have enough mass, to basically form a spherical enough object under its gravitational stress. And then we actually did discover other objects, such as this trans-Neptunian object, Eris, and they actually have a little cool diagram that he put in the video. And again, if you want to get into a real great analysis, in my opinion, Anton is one of the places to go. So it's all right. You see over here. Hold on. Boom. All right. So we got Pluto over here. We've got Eris, which is basically the same size as Pluto. Charon is one of Pluto's moons. And then you have all these other objects here. Basically, there seem to be some anomalies that we couldn't necessarily account for. Different gravitational anomalies, if you would. So that's why people had hypothesized, oh, maybe we got a planet 9. Maybe we actually have an actual planet, not a dwarf planet. I know. Rick and Morty did an episode of that. It's... Yes, pop size strikes again. But basically, we have these other objects, which apparently this seems to be roughly about the size of Pluto, maybe even a hair larger. Again, is that? Yeah, I think that's probably metric tons mass. Again, we'll get into the article. I haven't read the archive paper yet. Again, full disclosure. Yes, I'm totally lazy, but basically, with this new object, rather than people have postulated, all right, well, maybe there's a black hole about the size of an asteroid. Like, physically, it would have around the mass of a planet, but an asteroid-sized black hole is going to be very hard to detect, but it's also going to emit, or at least have a gravitational effect, if you would, on the other planets, and maybe be one of the reasons why it's, I don't know, why is Uranus kind of like going around on its side and everything like that. So with this new discovery, and again, this is something that apparently at some points in its orbit, it gets about the distance of Pluto, which is about 45 astronomical units. What's an astronomical unit? It's basically the average distance from the Earth to the Sun. Well, that's about like 93 million miles or something like that. Really frickin' far, and that's why it takes about 8 minutes for light from the sun to reach the surface of the Earth. Okay. So basically, about 45 of those, so like millions and billions of kilometers away is Pluto, but this thing's orbit ends up sweeping out like, what's the furthest? Let me pop over to the paper. You go to the PDF. So basically they found it at, we'll actually share it, duh. If we want to do science, we should probably actually share things. There we go. All right, so here's the paper again. The links to all the stuff are in the doobly-doo below. So as we have here, the title, this was submitted about last week. Discovery of a dwarf planet candidate in an extremely wide orbit. And as Anton was saying, this is 2017 OF201. I don't think that's OnlyFans. I think that's our standard description for this. All right. So as we can see from our authors here, Si Hao Chen, Jixuan Li, and Eratas Yang, we report the discovery of a dwarf planet candidate. All right, as we said, currently located at a distance of 90.5 astronomical units. That's frickin' far. Its orbit is extremely wide and extends to the inner Oort cloud. All right, so the Oort cloud is that stuff that's really frickin' far away. Let's actually just go to it. Hold on. Let's go over here. Oort cloud. All right. So basically, it's. Let's actually go to the actual Wikipedia article. Okay, and make it a little bit bigger. All right, here we go. All right, so the Oort cloud is theorized to be a cloud of billions of icy planetesimals surrounding the sun at distances ranging from 2,000 to 200,000 astronomical units. So, all right, so about 0.03 to 3.2 light years away. Frickin' far. What is it? Alpha Centauri is about like 4.2 light years. So basically it's theorized that due to the gravitational effect, whatever that might be, of the sun, we've got basically an outer sphere of icy stuff. Okay. Can we, and if it's icy, it's probably going to be pretty cold. If it's pretty cold and it's not ginormous like Jupiter or something and it's really far away, it's probably going to be really hard to see. That's why it's really cool, pun intended, I guess, that we could actually notice something like this. Okay, let's go back to the paper here. All right, so all right, it's semi-major axis, so basically it's other axes. If you're kind of doing an elliptical thingy there, it's about 838 astronomical units with a perihelion of 44.9 AU. Precisely determined from 19 observations over 7 years, so that's probably why it's 2017. So basically, if we have initial things that we have found in 2017 and we've had future observations that have been able to confirm that this at least appears to be a dwarf planet candidate. Long story short is, if we've discovered a bunch of other things like Eris and this other candidate, then this is going to help account for a bunch of the other mass that we had previously had unaccounted for. Because if you see a mass effect happening, what's the simplest thing? It's like, oh, maybe it's another planet. Why? Because we've done that before, and it actually has worked out. Now, again, I realize this is kind of pedantic because, well, if you grew up like me and Pluto was a planet, it's like, oh, well, this should be planet 10 or maybe 11 or so. But again, if we're going to have a definition of what a planet is and something that's able to literally, via its own gravity, make a pretty spherical thing, and this doesn't have enough mass or gravity effect to actually be a planet, well, then we call it a dwarf planet. So the whole planet 9, something that would be maybe the size of Neptune or something like that, or perhaps it would be an asteroid-sized black hole. Now we're accounting for a bunch more of that mass. So unfortunately, it's not looking good for the Planet 9 hypothesis right now. That's also a very clickbaity title. Full disclosure. So let's continue into the paper itself. So let's bring it up over here. All right, so let's go through this. All right, so we'll read a little bit and we'll skim through. So while the Earth asteroid belt contains only about 0.04% of the Earth's mass, so basically this over here, that M with a little cross is Earth masses. All right. The Kuiper belt. Kuiper belt. Oh God, I'm reading that. It's like I always hear that. Maybe I'm spelling that wrong. But Kuiper belt, the home to Pluto and numerous other icy bodies, harbors significantly more material with an estimated mass of around 2%. All right. So, full disclosure, the sun is about, what is that, like 98.5%. Pushing 99% approximately the mass of the solar system. Jupiter's around like 1%-ish around there, and then everything else is making up around that other couple of percent. Okay, I realize that's not, let's actually just double check this. So, sun, solar system, mass. Okay, so the sun accounts for 99.86 the total mass of the solar system. Let's double check this. Let's go to space.com. That sounds trustworthy, even though that's probably where it's coming from. 99. Okay, so at least according to NASA, let's actually go to NASA. Sun, 99. Okay, so at least according to NASA, it's about 99.8% of our solar system mass. All right. Oh, because they're referencing the Earth's mass. Okay, that's why I got thrown off there, because we're talking Earth masses, not solar masses. Listen, you spend enough time on Wolfram Alpha, you do a bunch of crazy calculations, in ginormous things, you're going to see solar masses very often. That's my mistake. All right. So basically, we've got about, what is that? That's, about 5 times more massive material in that area there. All right. So even greater mass is believed to reside along the classic Kuiper belt and the scattering disk and Oort cloud, which may together contain up to several Earth masses. These distant reservoirs of comets, small bodies, minor planets, and possibly undetected massive planets hold essential clues to the formation and evolution of the solar system. All right. So 30 years after the discovery of the first trans-Neptunian object, TNO. Other than Pluto, various survey programs have been constructed to explore the vast regions of the outer solar system, and more than 5,000 trans-Neptunian objects have been discovered so far. Although the census of large TNOs near the ecliptic plane is nearly complete, but it remains highly incomplete. There are regions that are beyond basically 60 astronomical units. So basically, once you're getting outside the realm of Pluto and everything, yeah, long story short, it's hard to see. It's hard to see. Because it's really freaking far away. All right. So let's see. Our pencil beam reasons. Okay, so basically, if you're projecting something out and you're having a very wide shot, it's kind of just think about your standard camera. If you have your camera and you're taking a wide shot, you're getting a whole bunch of stuff. But if you're trying to zoom in and you're trying to have it as focused as possible, you're going to try to increase your resolution because you're zooming in and you're basically looking at more of a point there. Fortunately, recent cosmological imaging programs, though not dedicated to solar system science, offer a promising solution to this limitation. These surveys definitely provide wide sky coverage, deep photometry, and multiple epochs that are well suited for the detection of faint solar system objects. A prime example is the Dark Energy Survey Collaboration, DES, or DESC, not to be confused with DESI, which is kind of doing the same thing, but it's a different project that I have totally mixed up before because nobody's ever heard similar things and then thought they were the same thing. At least I do all the time. All right. In this letter, we report the discovery of a large and exotic trans-Neptunian object, 2017 OF201, from a systematic search in the archival data of another extragalactic survey similar to DES. This survey is called the Dark Energy Camera Legacy Survey. Yes. All these acronyms that are similar has never confused a person before. Okay, so, all right, the 4-meter Blanco telescope. Ooh, this is the first time I've heard about this. Very cool. All right, so, hey, Bill, good to see you. I decided to see if you did not get an audible alert. I don't know if there's supposed to be an audible alert on this. It all depends on how you have it set up. I know sometimes it's, if you happen to follow a particular channel, you can set it there depending on if you want to get all the different things, all those other things, or you could set up different notifications. For me, it's like, I usually just open up the app and I just see my notifications. If I try to set reminders of something, my thing would be going off all the time. I follow way too many different folks. I usually personally just let the algorithm decide for me. I mean, that might be a very bad thing, but I found that the algorithm shows you what you seek really well. And as somebody that came from the greater political sphere of when I was following a lot of outrage stuff, it showed me plenty of things that made me really angry. So I stopped following those things and I went down my science hole, and now it recommends things that I personally at least find useful. And again, that's me personally. Whatever you want to do, you do you, boo. Hey, Zombie. Good to see you, my friend. Thank you for popping in. Yeah, so we're just talking about how Planet 9 may not be a thing anymore. Because again, just to recap here, and again, we're getting all this different stuff here, and I'm not going to pretend like I know all what this means or anything. I'm not an astronomer. I'm not a cosmologist like Professor Keating or Professor Carroll. I'm a dude on the internet. I was looking for something to talk about. I'm like, I could just keep on talking about the things I'm working on, but it's like, you got to get into some different science news and stuff. And this was one of the things. And again, Anton recently posted a video, so it's not like I start off the thing with a little bit of Anton in it and play it, and that might algorithmically link us and be beneficial. But I mean, hey, I digress. Full disclosure. We want to be as open and transparent as much as we can. So let's go into other things here. So let's go into the discovery section. All right. We performed our search in a similar way to Bernardinelli et al. And optimize it for the sparse epoch sampling from that previous study. Details of the search algorithm will be described in a future paper. So far, this particular object is the most interesting object found in our search with the largest distance and widest orbit. Okay. So after identifying 10 detections within the data, all right, with 3 different bands, all right, from 2014 to 2018 and connecting them with a tentative orbit, it became rather clear that they are corresponding to a single moving object that has an extremely wide and eccentric orbit. In addition, with an apparent magnitude of 22.6 meg at a distance of 85 astronomical units, all right, so we're pushing around twice the standard distance from Pluto. So they're going through there. It has the second brightest absolute magnitude among 411 known trans-Neptunian objects with wide orbits that are greater than 80 astronomical units. All right, from the JPL small body database. All right, let's go through here. So putting it together. Let's go to the properties next. All right. So we performed precise astronomic and photometric measurements. Meteorology, that's Bill's expertise, on each of these 19 detection images to determine the orbit, color, and absolute magnitude. All right. A summary of the derived properties are listed in the table 1. All right, let's go to it. All right. So, astronomical units. All right. So apparently it looks to have around an average, and again, it might be around like 40, around the distance of Pluto now, but it can get really, really far out there because if the Oort cloud is around, what is it, like 1,000 to 2,000 astronomical units, yeah, we're like halfway there. So it seems to be something probably around, looks, do they have mass in here? Mass in here. They have to have it somewhere. Computed, via the Find Orb software. That's a fantastic name. What are we searching for? We're searching for orbs in space. How do we do it? We use the Find Orb software. Beautiful. All right. Okay, so that looks like the eccentricity. Okay, so the parallax tracked by 5% over the 7-year observation. So the parallax, at least what I remember from my astronomy class, because I did actually take an astronomy class at one point, is you look at something and, all right, you got something here, you close one eye, you open, and then you cover the other. It looks like it's moving very slightly. That's essentially the same concept of what we're doing, because if you can have multiple observations, especially from different points, where basically have the ability to actually try to judge as best we can, and based upon our equipment and our ability to measure about how far away it is. Now that works great with things that we can have direct eyes on. The problem we run into is once you start getting really, really far away, like once we start getting out of the solar system, and especially if we try to get out of the Milky Way, parallax becomes perhaps much harder. So we have to start using cosmic distance sliders and everything. And a lot of that data, and credit to Professor Keating when I asked him this, is, so what happens if our cosmic distance ladder is off? And he's like, hey, listen, this is the best that we have at the time, given our current instrumentations and our understanding of the cosmos. So that was an honest answer, and I appreciate that. And again, James Webb seems to be updating, give us a lot of data that a lot of our old models, perhaps for galactic formation, perhaps via what's actually going on within our cosmos, we might have to redo some of the textbooks. And I think Shiloh, shout out to Shiloh and Anastasia from the Demystify Sci podcast, is, I know Shiloh does teach like an introductory astronomy class at the university in, I think, Oregon. And even he was like, listen, I'll have the textbook. I'll be preparing for a class. And also I go back, it's like, the textbook literally just updated because it's a digital textbook, so they can do that. So personally, I feel like anytime you're going to have updates like that, you should, at least for World of Warcraft, when they do patch updates, they should probably at least cover what they changed, kind of like a Wikipedia article is supposed to. If you're going to take something out, that's fine if it's not relevant, but just leave a note about who did it, why they did it, and perhaps it should have been re-included. Who knows? All right, so what do we got? Blah, blah, blah. All right, so the last time 2017 OF201R, this big newly discovered trans-Neptunian object, passed close to us was in November of 1930. All right, so they've got some calculations for that. And it will come back again in about 25,000 years. Interestingly, this last perihelion was the same year of Pluto's discovery, February of 1930. That's neat. When this trans-Neptunian object reached its maximal brightness of about 20 magnitudes, about 4 magnitudes fainter than Pluto. So technically, if we had slightly better telescopes at that time, we may have been able to discover this about, I don't know, like, was it like 95 years ago? Yeah, about 95 years ago. Except rather than, yeah, it seems to have, this is not, was it? Halley's Comet is about 78 years for its cycle. Hale-Bopp is, was it like 100-something years, maybe 1,000, I don't know. Around that magnitude, yes, that's a huge difference, but so 25,000 years. So maybe he'll visit us in maybe the next ice age, or who knows. All right, so let's go through here. All right, so hey, Keshal, thank you for joining. Thank you for joining. Yes. We might be, this may be the funeral of the Planet 9 hypothesis. I know, it's very sad. So let's go through a wee bit of the history about some of this stuff and how we kind of think about these things. Because a lot of times you see things in the sky, especially the planets. We called them planets, and we named them after, like, the gods of the time. So we had Jupiter, basically the king of the gods, Saturn, Venus, Mars, yada, yada, yada. And like, you could literally see it with your eyes. If you have to have good enough eyes, you could judge and you could see them, because the stars appeared to be fairly set there. But in relation to the other things, these planets were wanderers. They seemed to be wandering across the sky, so we attributed them with some anthropomorphic characteristics, because that's obviously the gods in the sky. They're roaming the heavens, because that's what gods do, right? All right. But as we got better instruments, like the telescope and everything, we began to actually, like, physically see better, and you could start to, like, make out the rings of Saturn and everything, and that's really cool if you actually happen to have a high enough power telescope to start looking at it. It's pretty neat. I know over here at the university they'll have different astronomy nights, and they'll kind of have, like, the big, I think it's probably about like a 30-inch telescope there, but then you'll have like a couple other like 10 or 12-inch telescopes outside the main little observatory, and you can look up there, and very often, if it's clear night, yeah, of course you're pointing at Saturn. Why? Because it looks freaking sweet. But we could start to detect those things. But then there were certain things where we're like, there seems to be something else going on, because of whether it happens to be some form of a gravitational effect, again, whatever the heck gravity is. If that starts to happen, we started to conjecture. It's like, well, maybe there's some more planets. And you know what? There were some folks where they did some calculations. I believe that's how we found Uranus, Neptune, and stuff, because, well, those were further away. And let's face it, if they're not quite as ginormous as Saturn, and it's a lot further away, it's probably going to be hard to see. Okay, so we ended up intuiting that, well, maybe there should be some things in these orbits to help account for the different mass effects and everything. So it's like, all right, cool, let's look into that. And then eventually we found Mercury and everything, and then it's like, well, maybe there's something else here. Why? Because something seems to be tugging on Mercury, so maybe there's another planet over there. oh, it would be really close to the sun, so it'd be really hot. So let's call it Vulcan. So we are searching for planet Vulcan, and a couple of times we kind of thought we found it. Ultimately, those didn't pan out, and it ended up turning out that when we thought we were seeing Vulcan, we were actually just observing the lack of precision of Newtonian gravity, to my knowledge. Again, I could be wrong there, but basically, it took good old Albert Einstein to come around with the precision of general relativity to give us an extra about 7 digits of precision, past the 7 that we get with Newtonian gravity, or at least according to Professor Penrose. And then once we realized, oh, well, it seemed the gravitational effect, once we had those extra digits, seemed to account for that whole perihelion, why Mercury seemed to kind of have almost a little bit of a retrograde thing going on there. Okay, so if we have that, then, well, we should be able to do other calculations. And that's why the whole Planet 9 let's actually just go to it. First, let's go to Pluto. Why? Because within my lifetime, it's been downgraded. I know. Okay, so Pluto, minor planet designation, is a dwarf planet in the Kuiper Belt, a ring of bodies beyond the orbit of Neptune. It is the ninth largest and 10th most massive known object to directly orbit the sun. It is the largest known trans-Neptunian object by volume, by a small margin, but it's a little less massive than Eris. So that original picture that we had, was it over here? So as we can see, yes, it is physically larger by its size, but in its mass, all right, Pluto, 134, 136, Eris is more massive than Pluto. Okay, so it kind of hence where we either add these as planets, but if we're going to go by our standard definition where it really needs to have enough gravitational effect to make it pretty spherical. Again, no, true, it's more of a spheroid. But if it doesn't have enough gravity to do that and fit the definition, hence why it got downgraded. Okay, yes, don't tell the Plutonians that. Again, Rick and Morty. All right, so let's finish going through. Like other Kuiper Belt objects, Pluto is made primarily of ice and rock and is much smaller than the inner planets. Pluto has roughly 1/6 the mass of the Moon and 1/3 its volume. Originally considered a planet, its classification was changed when astronomers adopted a new definition of planet. Professor Tyson! Again, he's just doing his job. And again, that's science. We want to cast off our misconceptions because science is the quest to be less wrong. I mean, if you're not seeking to be less wrong, I mean, what are you trying to do? You're just trying to say, I'm right. Why? Because it makes me feel good. Yes, nobody would ever do that on the internet. But I digress. All right. Pluto has a moderately eccentric and inclined orbit ranging from 30 to 49 astronomical units. Okay, so as we saw here is if Pluto tends to be around like 40, 45 astronomical units, that's really freaking far as we can see. Yeah, that's about like 7 billion kilometers or a little shy of 5 billion miles from the sun. Yeah, that's really freaking far away. Yeah, so light from the sun, it takes like 5.5 hours to reach Pluto at its orbital distance when it's at about 40 astronomical units. All right. So Pluto's eccentric orbit periodically brings it closer to the sun than Neptune. I remember that from back in the day. It's like, Pluto is the furthest planet, they would tell us. Yeah, most of the time. Why? Well, it kind of crosses around Neptune. That seemed kind of weird. So even at the time, people were like, yeah, Pluto's kind of weird, but we kind of know it's there. Disney has a dog named after it, so we'll just kind of go with it, right? All right. So, but stable orbital resonance. Okay. So apparently, orbital resonance. In celestial mechanics, orbital resonance occurs when orbiting bodies exert regular periodic gravitational influence on each other, usually because their orbital periods are related by a ratio of small integers. Okay, that's cool. Okay, so long story short, it looks like Neptune and Pluto hopefully won't crash into each other. Okay. Pluto actually has 5 moons. Charon, the largest, I think that's also one of the gods of death from Greek lore, I believe. Or maybe it was Roman. All right, so let's see, because we can go, all right, blah, blah, blah. All right, not that. Oh, yes, yeah. Charon, Styx, Nyx, Cerberus, and Hydra. Yeah, that sounds like Greek mythology to me. All right. Pluto and Charon are sometimes considered a binary system because the barycenter of their orbits does not lie within either body and they are tidally locked. So again, you go over to the picture. That's pretty dang big compared to the size of Pluto. So that's probably around the size of our moon to our size. But then again, we're a lot larger, and as Earthlings, we actually happen to live on the densest place in the solar system. Why? Because Earth seems to be made of a lot of iron and nickel and stuff like that, and that's pretty dense. And actually, I learned from Shiloh that apparently the density of sun is approximately the density of water, which is fascinating. And let's just feel free. Density of sun. All right, so as we can see, all right, so about 1.4 grams per centimeter. And the density of water is about 1 gram per centimeter. So let's divide by density of water. 1.412. Ooh, that's interesting. I feel like I looked at that before. That's not quite root 2, but because I like to go down Wolfram Halls. Okay. Oh, wow. Okay, so it is pretty close to root 2. That's... Never mind. Again, about the density of water, at least the magnitude thereof. All right. Back to Pluto, my friends. Let's see. Hey, welcome, Poindexter. Yes. And again, I'm not going to pretend I'm not an astronomer or a cosmologist or anything. This just seemed to be pertinent news. And also, occasionally, you'll see a lot of videos because, again, nobody would ever do clickbait on the internet, but it's when you see folks saying it's like, astronomers are terrified about what they observed here. And then you go through the video and you're like, yeah, that has absolutely nothing to do with what you're saying there. I tend to personally feel that the easiest way to solve those issues on the internet is monetize news, monetize opinion. Make sure both are properly labeled. I know, imagine. We go back to the straight editorial style of newspapers. If you just want to report facts, that this was reported at this time by this person, according to this happened, this person said these things. If you just want to report facts and news, and that's often kind of boring, you can totally do that. But within newspapers, if you're getting to opinion sections, a lot of times people enjoy that. That's totally fine. Just label it opinion. Because, well, nobody would ever try to pass off their opinion as fact on the internet. I mean, just imagine the dynamic if some of our best reporters and commentators on the internet simply had to put opinion before their commentary. Just label it opinion. You're able to say all the standard things that you're able to within the YouTube guidelines, and you're able to monetize it. What if people know it's your opinion? I mean, that's fine. I mean, it's not like when I asked Tim Pool if he was really willing to lead the charge after he had pointed out, to his credit, on the Joe Rogan Experience, they brought up something from like Newsweek or something, and Joe Rogan's reading the title, and Joe Rogan's like, well, yeah, that's an opinion. And Tim Pool, to his credit, pointed out, yeah, does it say it? It did not. It did not say opinion. To his credit, that's fine. The point where I really kind of stopped watching Tim Pool was around the point where he started early doing the Timcast IRL, and I had sent a super chat and asked, Tim, are you willing to lead the YouTube charge by labeling your opinion segments opinion? And his response was, well, people know it's my opinion. Really? Rules for thee, but not for me. I've heard somebody say that a bunch of times. Yes. I'm sure it has nothing to do with your size and scale, and when you're fighting the good fight against whatever insert establishment here, it's not like once you become established, all of a sudden the establishment techniques and everything you begin adopting. Yeah, because that would be disingenuous. Nobody would do that on the internet. All right. Again, rant. Maybe we'll get into some of that. Again, I am a troll. Like, full disclosure, it's like, yes, I love science, but deep down, I am a troll. And I've been trying to play nice by doing mostly just science things. It's like, all right, eventually you start to get some attention and everything because, yeah, it would be nice to have this, like, fully funded and everything like that. It's like, yes, this think tank facility is fully funded. That would be fantastic. In the meantime, it's like, hey, you invest where you feel the investment goes. Again, I'm not outside of drama just because the standard drama. Okay, real quick tangent. So let's make a new window over here. Thank you, Anton. And all right, so this is a side tangent. I apologize, but all right. So why is the internet the way it is? All right, so let's go here. All right, so computationally reducing fine structure, 17 views. Paragraph 40 views. Most physicists don't know this. 33 views. Oh, hold on. Live streams. Apologies. Oh, we actually have folks watching. Thank you. All right. Can we solve the hierarchy problem? 75 views. Han destroys means 51 views. Calculate the proton, electron, and neutron's attributes with H-bar in high school algebra. 81 views, even if it's a loop in logic. I had to stop watching Eric Weinstein versus Sean Carroll. Oh, look. We're pushing 3,000 views now, and that's... Literally, I listened to it. I'm like, I couldn't keep watching. I played a few little things. It's like, all right, Dr. Unzicker. So we got a picture of Unzicker. He's a larger channel. Get a few more views. Breaking the multiverse. All right. Yeah. What do we notice here? You talk about drama, you get engagement. All right. So that just explains a lot in my opinion. All right. So let's, all right, let's pop into our friends in the chat here. All right. So Bill, aka Gravity for the Masses, is commenting. I like how Pluto has more complex features than our moon. It looks like a tiny ice road. Our moon looks like asphalt with craters. I get what you're saying. I think it's actually like a lot of regolith and stuff. It's supposed to be pretty dusty. That's why ultimately they had to design new spacesuits, and this became a major issue because the old spacesuits, or at least for lunar transit. So basically, if we're going to go to the moon, the problem is apparently lunar regolith is quite abrasive, and we had old suits that worked well, but all the people that made those suits either are retired or are no longer with us. So we literally have nobody that was alive since the last time we went to the moon, or at least is actually working, that can design similar suits. So ultimately, at this point, it's like, all right, we need to heavily test these suits, because if we do send somebody back to the moon, you don't want them to be walking off the regoliths and be like, oops, there's a tear. That would be a very bad day. All right. So is it a bombshell? I cannot say. All right. So let's see. Well, Poindexter's commenting. There's a school of thought that everything is opinion. Well, opinions are like many things. So everyone has one. Maybe everyone needs one. You don't attend that school. Okay, well, hey, we all have different places. We all come from different histories, different roots, if you would, and everybody's different. That's the thing. Every time I try to prejudge somebody, I am often horrifically wrong, and very often end up just eating crow, so to speak. Not that I'm actually eating crow. I prefer chicken. Why? Because it's delicious. Why, thank you. That's one of the nicest things somebody's told me today. Intelligent base troll. I know, some of the most dangerous. Don't worry, there are far more intelligent trolls out there than me. But I digress. Oh, God. I mean, it's so small for... all right. Let's go back here. All right, so we got Pluto there. All right, so at this point, since we're coming towards the end... Oh, yes. Here's the picture from Wikipedia. And let's go back to... All right, Planet 9. Yes, let's actually get to the point. Not to be confused with Planet X, proposed in 1906 by Percival Lowell. This article is about the hypothetical planet first suggested in 2014 for the dwarf planet previously classified as the solar system's ninth planet, Pluto. For other uses, ninth planet to blah, blah, blah. All right, so Planet 9 is a hypothetical ninth planet in the outer region of the solar system. Its gravitational effects could explain the peculiar clustering of orbits for a group of extreme trans-Neptunian objects, ETNOs, bodies beyond Neptune that orbit the sun at distances averaging more than 250 times that of Earth, aka 250 astronomical units. These trans-Neptunian objects tend to make their closest approaches to the sun in one sector, and their orbits are similarly tilted. These alignments suggest that an undiscovered planet may be shepherding the orbits of the most distant known solar system objects, aka there seems to be some gravitational effect that we cannot account for. So, since previously unabsorbed gravitational effects, it's like, maybe there's another planet out there. And it seemed to work. That's, again, kind of how we got Uranus, Neptune, bada boom, bada bing, let's try it again. But ultimately with the redefinition of planet, because we want to update our definition so we can actually be accurate, because it's not like we're just going to scream out there into whatever's totally not the ether, to just scream enough that people will be like, well, that's obviously right. Why? Because this person just yelled a bunch and made a big stink about it. Because obviously rewarding bad behavior is the best way to stop it. All right. Let's continue. Nonetheless, some astronomers question this conclusion and instead assert that the clustering of trans-Neptunian objects is due to observational biases stemming from the difficulty of discovering and tracking these objects during much of the year. AKA, it's really hard to get good, clear pictures of stuff that's really far away, and especially if it's really chilly. Now, if it was like thousands of degrees Kelvin, if it was like even like a white dwarf or something like that, it's like, all right, it's probably going to be pretty hot. Even if it's several thousand degrees Kelvin or something like that, it's like, even if it was small, it would be hot, so we would be able to pick up those different wavelengths. Right now, it's like, all right, if it's really far away, and things like Bill was pointing out, if they seem to be mostly just covered in ice, that's pretty chilly. So it's very hard to be able to pick up, and it literally took like one of the dark energy surveys to help like locate this thing. That's pretty crazy because, again, they were pouring through the archival data, because if you see something, again, it's, I don't know, maybe it's just a stray cosmic ray. Who knows? Maybe it's a thing of dust. Like, before the lens, it could be that. But you want to have multiple observations and actually have confirmation. Because, well, that's science. Because, I mean, what was it? Back in the day, it's like magnetic monopoles. Because charge typically, charge comes off very much, what is it? Like a proton or electron. It's emitting charge, and it kind of seems to be doing its thing, but magnetism always works in like a dual way, aka you cut a magnet, it's like, all right, it still has poles. It's not like, oh, well, this is just the positive side and this is just the negative side. For some reason, every time you break a magnet, it's going to have like a north and a south, at least according to our general description as far as its impact there. But long story short, magnetic monopoles, there was a detection, like on it was on Valentine's Day, like a long time ago. So a person that saw this, the thing is, apparently we never really saw it again. Now maybe there had been, some people may have claimed that, okay, maybe they saw it, but it's one of those results that if we couldn't replicate it, it's like, maybe it was just kind of a fluke. So hence why we want to have as much good quality data as possible that we can go through and actually try to validate this. All right, so let's continue with Planet 9, not to be confused with Planet X, which is another thing, and or the planet that was eaten by a black hole in some of the Godzilla movies. Oh no, the Zillions are coming! The Zillions are coming! Oh, geez. Satire. All right. Based on earlier considerations, this hypothetical super Earth-sized planet would have had a predictive mass of 5 to 10 times that of Earth and an elongated orbit of around 400 to 800 astronomical units. Okay, so that kind of lines up with at least the orbit. of our other observational detection there. The orbit estimation was refined in 2021, resulting in a somewhat smaller semi-major axis of about 380 astronomical years. This was shortly thereafter updated to 460. All right, so we're jumping all around there, and then eventually in 2025, aka this year, it was about 290 astronomical units, plus or minus 30. So yeah, about the lower end of the range of Pluto there. All right, so astronomers Konstantin Batygin and Michael Brown have suggested that Planet 9 may be the core of a giant planet that was ejected from its original orbit by Jupiter during the genesis of the solar system. Others suggest the planet was captured from another star once it was a rogue planet, or that it formed in a distant orbit was pulled into an eccentric orbit by a passing star. Those sky surveys such as the Wide Field Infrared Survey Explorer, WISE, that's a cool name. All right. And banned stars did not detect Planet 9. They have not ruled out the existence of a Neptune diameter object in the outer solar system. Its ability, well, maybe it is now. What is it? All right, so it's purely conjectural. Let's see, have they updated this article yet? As we're getting to the end here. Let's see, citation. Okay, maybe people will wait until there's more reporting. All right, people are still conjecturing. And again, we conjecture because, well, it's fun. And that's why, if you're not wrong, then, well, how do you start doing science? Because we want to cast aside our misconceptions. All right, so, that's solar, or, no, that's Earth mass. All right, because we have there, all right. Where's the observation? Continue. Evidence. All right, so trans-Neptunian objects. All right, we've discovered a bunch of them. How long is this? Oh, wow, there's so much stuff on Planet 9. All right, so here's how we quickly find something. All right, so OF201. Literally, go in here, file, search. All right. So the only reference in the entire Planet 9 article is right here. So they have a link here. Let's take a look. All right. So it's an extreme trans-Neptunian object and dwarf planet candidate estimated to be about 550 kilometers in diameter. All right. So it's got an absolute magnitude of 3 or 4. It may be the brightest... It does not have a directly estimated size. What? Okay. Because that's interesting, because I think that's, what is that, like the solar albedo or something? Oh, that must mean it's very shiny. So when they say the brightest known object in the solar system, base reaction, you're like, the sun, dang it! It's obviously the sun. Yes, that is the actual brightest. But as far as at least shiny reflectivity, incorporating its distance, if it's really freaking far away and it's only slightly less bright than Pluto and it's much further away, there might be something there. Or at least that's my initial logic there. All right, so its current distance is about twice the distance of Pluto. The May 2025 announcement of 2017 OF may end up disproving the existence of Planet 9 and possibly planets beyond Neptune in general. The orientation of the orbits of extreme trans-Neptunian objects tend to cluster. This clustering led to the hypothesis that a possible distant planet has influenced those orbits. However, the orbit of 2017 OF is one of the few, such as some of these other guys here, that is anti-aligned to the calculated orbit of Planet 9. Modeling suggests the hypothetical planet would have ejected 2017 OF from its current orbit over timescales of less than 100 million years, although it could be a temporary orbit. Okay, so that's ultimately one of the biggest, quote-unquote, nails in the coffin, so to speak, of the Planet 9 hypothesis is if you actually did have a Planet 9 of several Earth magnitudes, and if it was going around the same place, it likely would have kicked this thing out of the orbit a long time ago. Hence, one might intuit maybe there isn't a Planet 9. Now, that's not to say that there isn't other stuff out there that we don't know, because, well, let's face it, most of that stuff that far away, it's incredibly hard to see, so how can we tell what's actually going on? It literally took, what, like 7 years of data combing through and then matching and probably using different algorithms and probably some AI assistance at this point now to help actually point out a pattern, I thought I saw a pattern, and then be able to trace out and estimate its orbit. All right. So it orbits far beyond Neptune at an average distance of, it's about 20 times the standard far distance of Pluto, which was about 50 AU. Taking 25,000 years to go around. Okay, so most of the stuff is from the paper. Okay, so let's go physical character. This is one of the reasons why I do like Wikipedia, because it's laid out in a very simple fashion. Okay, so the diameter is unknown but estimated, so as we saw, about 500 to 800 or so kilometers there, placing within the range of a possible dwarf planet. And then Pluto, for reference, is about 2,300 kilometers in diameter. So that means if you were to have a tape measure going straight through Pluto, it would be about 2,300 kilometers, or that's probably around like 1,500 or so miles. So this is a lot less. Yeah. As we can see, even Eris was slightly smaller. That's another trans-Neptunian object, but Eris appears to have slightly more mass than Pluto itself. So it's like, unless you're going to make all those planets and you're going to redefine the definition of planet again, they're dwarf planets. And yes, the Rick and Morty episode does seem to maybe hold some water, or beware mining the Pluto, because it might not. Okay. Feel free to watch it out. I ain't your dad or anything, but let's finish with paper. So, okay, yep, we got plenty of pretty pictures here. So, all right, so this appears to be one of the detections. I believe there's another detection over there. Let's see, we have go through for the last couple of things. All right, so yes, that's the same thing that we had from the article, and again, it seems to have a very eccentric orbit. Like a lot of planets, it's like, all right, we kind of have a general ellipse there, and then it's like, this one is out here, this one is out there. All right, so, all right, that's pretty much most everything we had. Anton went over this in the video. Again, feel free to, if you want a little bit more succinct, short coverage with a little bit more data and maybe a less little woo-woo and me kind of like going a little bit over the top here, again, feel free to check that out. Is there anything else that really strikes my fancy here? Okay, so again, the links to all this stuff is in the doobly-doo below. I may have done some things totally wrong, but I thought this was a kind of cool thing. And occasionally, with all the science stuff on YouTube and everything, you'll hear folks saying it's like, oh my God, and this clickbait video, but if somebody's like, Planet 9, they're going on and on about all this different stuff, it's like, you can just always ask, it's like, well, wouldn't Planet 9 have kicked out 2017 OF, like a long time ago? And then just await their response. Because the easiest way, it's just a Socratic method. Because it's kind of like unexplained phenomena in the sky, therefore aliens. Now, I'm not saying it's not aliens, it's just I saw something I don't recognize in the sky. The logic leading to therefore aliens, it's not there. The logic don't hold water there. Now again, maybe it is, maybe that you would do, it's just you would need more evidence for that. So if you start seeing folks going on about Planet 9, oh, the scientists don't want you to know. Maybe that is the case. Is it more likely that there's just a whole bunch of cold dwarf planet, aka trans-Neptunian objects out there that we haven't seen because they're frickin' far away and really cold, so it's very hard to detect them? That seems like a little bit more of a plausible answer to me personally. But let's continue with a couple of comments here. Let's see. Well, see, that's one of the big things, and I think we might be hearing more about that sometime after June 1st, Poindexter. We want to be careful about being tracked within certain dogma, because that may lead us astray. Well, Bill, that's the thing about human psychology. It's like I tried to start to figure out human beings and how we could all get along, sing kumbaya. I couldn't do it. I couldn't do it. Human beings are too complicated. That's why I'm like, all right, let me play around with some calculations. Let's go into science space because, I don't know. Personally, it seems like trying to figure out some of the bases of reality seems at least easier to do than trying to figure out humans. Why? They're freaking complex. So, yeah, well, that's the thing. We have different confidence levels. So it's like, we see something, oh, well, maybe this is planet 9. And you go through the observations, it's like, okay, maybe it's a dwarf planet, but to claim it's a planet given our standard now definition, thank you, Professor Tyson, that, yeah, it doesn't really seem to be the case. Let's see. Hey, Jez, good to see you, my friend. Hopefully you're doing well. Yes, it's, pardon. You don't need to watch Rick and Morty. It can, some folks are fans of it. You don't need to. It can be quite annoying for others. Well, that's the thing. You got to realize it's like the map is not necessarily the territory. They say the map is not the territory. I mean, yeah, because if you're trying to have a map of everything, well, you know, the best map of everything would be everything, right? So that seems like we have to model it because, well, we're computationally finite. So, Jez is recommending don't bother after season 3. I think they're on like season 8 or something. I think Tony told me that. But other than that, we filled up our hour and everything. I think it's about time for dinner at the old monastery. So, hey, thank you all for joining. Those who are watching now and temporally in the future. And just be wary of clickbait on the internet. And a few well-posed questions. I believe it was Darren Stevens that said, a slip of the lip can sink a ship. So with that, peace out, everybody.